Welcome to this Maths Made Easy video on normal approximations to the binomial distribution. To start with, let's take a look at continuity correction. Now, an obvious problem with this approximation is that the binomial distribution is a discrete distribution, while the normal distribution is a continuous distribution. So this means that the binomial distribution takes fixed values with certain probabilities, but the normal distribution only takes values on ranges, i.e., for discrete distributions such as binomial, we can work out probability that x equals 0, the probability that x equals 1, and so on. However, for continuous distributions such as the normal distribution, if we wanted to work out the probability, say, of y equals 0, well, that would be equal to the probability that y equals 1, and so on. And the reason for that is because they all equal 0. Okay? We can only work out probabilities of ranges of values. So this means that for our approximation, we need a continuity correction, which works like this. Let's say we've got the probability that x equals a. In this case, we'd write this as a probability of a minus 0.5. And this is for the variable y here. And our upper limit is a plus 0.5. Okay. Now, for example, if we had the probability that x equals 1, that would look like this. That would be the probability of 1 minus 0.5, so 0.5. And our upper limit in that case would be 1 plus 0.5, giving us 1.5 there. Okay. For the probability that x equals 2, so if we write this here, the probability that x equals 2, then again, just applying this rule here, that would be the probability, my lower limit here being 1.5, and my upper limit being 2 plus 0.5, giving us 2.5 there. Okay, and so on. And this table here is quite handy in giving us a nice brief summary for continuity corrections in practice. So we can see this probability that x equals a here. We've already demonstrated this one here. Okay, and that includes a. If you were looking, say, the probability that x is greater than a, then we'd write this as a continuity correction as a probability of y being greater than a plus 0.5. And we could see that would exclude a. Okay. For example here, the probability that x is greater than or equal to a, well, we'd write that as a probability that y is greater than a minus 0.5 because we need to include a there. Okay. And a similar argument follows here when looking at x being less than a and less than or equal to a. Okay. So that gives us everything we need there for continuity corrections. And finally, let's take a look now at conditions required for the approximation. Now, you can only use the approximation under some circumstances, and you must make sure these conditions hold before you can use the approximation. So, you can use the approximation when p is approximately 0.5 and n is large. Or, we can say here that both np, so n times p, is greater than 5, and n times 1 minus p is larger than 5 here. Okay, so those are the conditions that we require for the approximation. So that gives us everything we need there, and that concludes this Maths Made Easy video on normal approximations to the binomial distribution.